Hey, this is Tyler Monroe for the circuit building project for Music 112, Section 1. Professor Riley. Um, Basically, what we're doing is we're going to be putting a bunch of resistors, capacitors, and inductor coils together and just creating circuits to alternate the sound of this stereo here. And yeah, I'm just gonna. I already have this playing. I got it set up, volumes all the way up, tracks playing. So I'm just gonna connect the speaker and the stereo and show you that works. Okay, so that works. Okay, and now the first step for me to do is to connect a resistor being 100 ohms or less into the speaker. This speaker is already 8 ohms, so once I connect it all together, I'll let you know how many ohms of resistance there are. To start off, I'm going to use this resistor right here. It's I don't know if I'm putting it up the right way. I don't know if you can see it, but it's brown, black, brown, and gold. Brown means it's 1, black means it's 0, third brown means it's 10 to the first. So it's actually 10 ohms of resistance plus the tolerance, which is plus or minus 5%. So that should be fine for the connection. I have alligator clips here. Connect it. And here's the last one. There you go. There's the sound. Volume is all the way up. If I had to guess, yeah, if I had to guess, it sounds like it got quieter, a little dimmer, but I'm gonna compare the two. Yeah, I got much quieter, much quieter. Here's it with the resistor again. The audio signal is way quiet. One more time without the resistor. Just tons louder. So with our 10 ohm resistor and the 8 ohms of resistance that we get from the speaker, with 18 ohms of resistance going through, or not going through, holding back. There's that again. Yeah. All right. Next circuit, I need to add a second resistor in the series, also 100 ohms or less. Now I'll tell you how much resistance there is in the series from there, and then yeah, we'll see how the circuit build is affected. So this one right here, this resistor is orange, white, and brown. I believe orange is 3. Let me check that real quick. Yeah, orange is 3, white is 9, and then it's brown again, so it's times 10 to the first. So it's 39 ohms plus the tolerance. Yeah, 39 ohms plus the tolerance. So we're going to put that in series, meaning after I do this resistor, I'm just going to put this resistor on the end of this alligator clip. So it's like you have two resistors in a row. Here we go. Well, that's much quieter once again. And I don't know if I'm necessarily hearing that it's cutting out frequencies. But once again, we'll look at the unaltered. Here's unaltered audio. Well, maybe it is altered a little. Again, the unaltered audio, much louder. I'm going to listen to the altered audio again. Maybe there are frequency cutouts, because I mean, I think the loudest thing in a drum set when you record it is supposed to be the snare and the kick. And I could still hear the hi-hat and the crash. So I don't know if I'd say there's any frequency cutout, but it's definitely way quieter than one resistor and then unaltered audio. And the total resistance, we have 10 here, 39 here, that's 49, plus 8, that's 57 ohms of resistance in the circuit. So yeah, there's that. Okay, moving on. Now I need to rearrange the resistors so that they're in parallel with the speaker. So, hopefully I do this right. I think I know how to do it, but you never know. Okay. Hmm. I need the mini, should I? Dang it. Maybe I'm not doing this correctly. Huh. Well, gonna continue the video, but pause in the process. This is a circuit I'm trying to make. The sine waves stands for the console itself. The console itself right here. This obviously stands for the speaker. And then I'm trying to create a circuit where the resistors are in parallel with one another. Maybe I'm not doing this right. Maybe I don't have enough alligator clips. I'll show you what I'm doing right now. Maybe I'm confused. Okay. So right now I got 2 alligator clips started on the console's wire, and those go up to the first resistor. And I also connected the second pair of alligator clips to the resistor. I don't know if that's incorrect or correct, but then I have it coming up to the second resistor, both of those alligator clips. Now I want to connect it to the speaker wire, but I only have 1 clip left. So if I was doing it correctly, I don't believe enough alligator clips. But okay, check on Google real quick. Google Images and see if I'm doing a circuit in parallel correctly. And I just don't know. I might just try to use where'd the video go? There we go. I want to see if I can just use one of these wires and just touch them together, see if that will work. Maybe, maybe not. But yeah. There's our image again. So I'm going to try to stick with this design, see what happens. And if it works, but I did it wrong, I'll still tell you the resistance that it's supposed to be. It's added up differently than resistors in series. Okay. That's not working. So maybe I could just use one of these clips by themselves, or a couple clips by themselves. Let's see what happens. I'm not getting anything, it's not paused either, so I think I'm just doing it wrong. I'm gonna look online again real quick. Dang it. It's showing me circuit schematics. I almost gotta connect it with alligator clips. Okay, I understand how to add it up. It's the connecting part that's killing me. Anyway, we'll try it again. So I'm gonna try to go the step by step. So here we have the console stereo system, and I wanted to connect to the first resistor like that. So in my mind, I'm gonna show you what that is in my mind. In my mind, it would connect like that. Where's 2? Connect like that. And then from that first resistor, need to connect on both sides to the second resistor, make it in parallel. I don't know if I need to connect to the alligator clip or connect to the resistor itself. That's the tricky part. You know what? This time I'm going to try the alligator clip. Why not? I think I'm still going to run into the problem of I don't have enough alligator clips if I do it this way. But it's worth a try. Okay. And I have the top connected like that again. So I'm going to try the last alligator clip I have. Maybe I'll just run downstairs real quick and see if I can find an alligator clip that I can steal real quick. There's that. Okay, so it works. I want to see if I can. Yeah, there we go. Maybe I can. Open both at once. It makes me wonder though. I'm gonna try it connected the resistor real quick. Because I don't want to just be flowing through the alligator clips and call it good. Nope, nothing. So I believe I do have to be. I think the alligator clips need to be connected within themselves. And then the resistors play a part, but yeah. So I'm going to show you the altered audio with the resistors in parallel. Hopefully I'm doing this correctly. And then I just don't want this other component to be touching anything else. Okay, so it's working. Now I want to try to do it unaltered so I can compare. I'm just going to disconnect here and here. So about that, unplug a bunch of things. I feel like it's a little quieter, but not nearly as much as when the resistors were in series. So we're going to check that again. Maybe I'll be able to tell a difference on the video more. Okay, so there's that. Well, I'm just worried. By the way I clipped alligator clips, the signal is flowing straight through without taking heed of the resistors. So I'm gonna try another idea, possible design idea that just came in my head. Hopefully it works out like I thought it would. Okay. I'm trying to do it like this now. Hopefully that works. I just didn't notice a huge audible difference between normal and what I thought was in parallel. Where do I go from here? Huh. First, I'm gonna flip this around. Okay, why did the lights turn off? There we go. Yeah, this design's not gonna work with as many alligator clips as we have. So yeah, a little frustrated. That's alright. Happens. One more time, I'm gonna try to look at Google and see if I can find stuff. Okay, real quick, I'm going to try to do the math, and I just dropped one of the resistors. I'm going to try to do the math, and see if there should be a noticeable resistance difference. If not, then maybe that's why there's not a huge difference in the audio. Get out my calculator. Sorry, this is taking so long. Okay, so we have one resistor in parallel. I believe that's the 10. So either way, if we put that first or second, it doesn't matter. We're gonna add up the reciprocals of what the actual resistances are. So we 1/10 plus 1/39 plus 1/8 from the speaker equals the reciprocal of the total. So 1 over RT. I'm going to add that together real quick. Okay. Hopefully I can get that in decimal form. Or fraction form. Wow. I think because it's very hard to get a common denominator for that, it doesn't really come up in fraction form. So it did equal about 0.25. It's 0.2506 plus, and then some more decimal numbers. But I think you should be okay with 0.25. So that's technically 1/4. So the total resistance is actually 4. Because the reciprocal of 1/4 is 4. So 4 ohms. And that explains that. If I connected it correctly, it won't have a huge difference at all. So I'm going to reconnect them one more time, the way I had it before. With only 4 ohms of resistance, I doubt there's any noticeable audible difference. So. There's that. And yeah, it's a little quieter, but I didn't really, there's not that much of an audible difference because of the small resistance. So again, because it's in parallel, you do the reciprocals, the total came out to be 4 ohms. Oh, now another interesting circuit. Okay, now I need a 5,000 ohm variable resistor, so I gotta remove these regular ones out of the circuit. Just stick my resistors over there. Okay. Now I need a 5,000 ohm variable resistor. This is A5K, so I believe that should be good. But I'm just gonna look at the other ones to make sure. Yeah, it's 100K. Yeah, I think 5K is what I need. This one doesn't. Oh, yeah, that's 100K as well. Yeah. So here's my 5K variable resistor. Okay. Yeah. All I have to do is connect the circuit first and foremost to the middle terminal here. I don't know why it's bent. I don't want it to be bent. Well, I'll deal with it. And then I have to connect to one of the other outer terminals. Connect to the speaker. And from the speaker back. Okay. Right now I'm connected to the right terminal, so I'm gonna start turning it. Okay, and turn to the left, turned it off. Or made it silent rather. Start turning to the right. It's almost like a volume knob. This is just a passive or active. Crap, I can't think of it whether it's a passive or an active component. By turning it on all the way, I'm actually but turning it to the right all the way, I think technically I'm turning it off because I'm just letting the volume that's already coming out of this come through the circuit. This is me turning it all the way to the right. Yeah. I forget. I believe that's full volume though. But then I'm going to connect it to the other terminal and see if it works just the opposite way. Yep. Okay, so like, I guess you could compare that to a guitar. Depending on what side you connect it to, will determine what side is, like if I plugged this into a guitar right now, it'd be backwards. Yeah, turning it that way would silence the volume. Turning it to the right or to the left, depending on how you look at it. Turning it this way would silence it on a guitar. Turning it that way would turn it up on a guitar. So it really does depend on which terminal you add it to. So yeah, there's that. Okay, now we're on step 6 in the handout. I just need to remove the variable resistor. Ooh, now I'm going to connect a capacitor, a 10 microfarad capacitor in series with the speaker. And those are up here. There's 1,000 microfarads. This is it. And this one's, they're connected. Okay. Yeah, 10 microfarad, 50 volt. Okay. Simple enough. Let's connect the capacitor in the series. I think that cuts out the lows a little bit. I don't know if it does really anything to the volume. Yeah, I'm going to start it over. Now I'm going to connect it. That's really basic right there. I think the capacitor actually cuts out the lows. That'd be my guess. But we will see. Yeah, absolutely. I don't think it necessarily does anything to volume, but I think it definitely cuts out the lows. Yeah. Okay, now step 7. Now I have to connect a second microfarad in series, or a 10 microfarad capacitor in series. Sorry. Oh, I mean, it didn't ask me to do this at step 6, but I'm going to do it anyway. I was asking about capacitors in series. Is how much resistance they show? Oh no. In series, you do the reciprocal. I believe it's the resistance. I don't know how many ohms it is though. Oh, the capacitance, sorry. The capacitance in this series, you actually take the reciprocal. Since there's only one, it'd be 1/10 of a microfarad. So yeah, that's a capacitance because it's in series. Or yeah. Anyway, sorry, I'm getting off track. Now I have to connect the second capacitor in there. Yeah, the same one. Okay. Again, we're on step 7. 2 10 microfarad capacitors series with one another. No, I paused it. Huh. How about that? Nothing. Doing it in series should be simple enough. I did the one by itself. I'm gonna play again. That's not playing at all. Oh. Okay. Yeah. I think it actually added. More lows and bass to it. Here's 2 capacitors again. Maybe. There we go. Okay. And here's 1 capacitor. Huh. I found that strange. I thought it cut out the lows the first time. Now I have to reevaluate my number 6. Okay, so that's without a capacitor. Yeah. This is original. And that's with the capacitor. Okay, it doesn't necessarily cut out the bass, but definitely I think a lot of the low tones, maybe even some of the high tones, get cut out. It's a lot thinner overall. So that's my evaluation on 1 capacitor, right, reevaluation. Dude, I'm so sorry this video is so long. And why is this not clicking? Oh, another 10. No, it's not going at all. There we go. Okay. It got a lot thinner that time too. Maybe a little fuzzy. But yeah, I think all frequencies just dropped down. Got quieter, it got thinner. Definitely didn't really sound like a good drum kit. So, okay. Now I'm going to add the capacitance together. They're both 10 microfarads. So when you add them in series, they're reciprocal. 1 over 10 plus 1 over 10. So 1 over RT. That's simple. It's 2/10, which equals 1/5. Reciprocal of 1/5 equals 5. So total capacitance is not RT, it's CT. Total capacitance is 5 microfarads. Yeah. Okay, now. Now I'm going to move on to step 8. Almost done. Okay. Now I need to rearrange it so the two capacitors are in parallel with one another. And then add the total capacitance to the circuit. Talk about how the audio signal has been affected. I just want to say, Professor Riley, I'm sorry this video is taking way too long. I gotta spit my gum out. And there's no chicken. Okay. Step 8. Rearrange the two capacitors so they're in parallel. Okay, I'm going to do it the same way as I did with what do you call it? Resistors. And there you go. I was having trouble with capacitors when they were in series. That shouldn't be a problem. But yeah. Okay, so there's that. I don't know if there's an actual audible difference. Oh, sounds like there is. That's a really strong signal right there. Very, very strong. I think it gets a little quieter. Yeah, there's definitely got a ton more power on the kick, at least. Now I'm going to compare the cymbal noise. I think the snare might be at the same level as it was before. Possibly. I mean, not the snare, the hi-hat. But I think the bass loses a little something during that part. And now I gotta calculate the capacitance when it's in parallel. When you do capacitance in parallel, it's the same as doing resistors in series. So I have two 10 microfarads in parallel. So it's 10 plus 10 equals 20 microfarads. Okay. That should be correct. Yeah. I don't think the speaker does anything to capacitance. It only does things to resistance. I could be incorrect on that, but I don't think I am. Grade me wrong if I am. Okay, now step 9, remove the capacitors and add a coil of wire in series with the speaker. How has audio been affected? Test all 3 colors of wire, which one affected the audio the most. The coil that has the highest inductance is the one I'll use in the next circuit. Okay, I'm done with capacitors. And actually, there's one in step 10, but for this step I'm done. Okay. Okay. Coil wire over here. Simple enough. Well, so right now, there we go. Okay, so there's the green coil of wire. Definitely sounds thinner. I don't know. I think it sounds thinner to me, personally. Yeah, definitely not as much power in that bass or the kiss in the snare or the hi-hat. So yeah, I'm just not feeling it, I guess. It's definitely a lot thinner. I mean, that's the word I've used over and over again. I don't think it's cutting out. If it's cutting off frequencies, it's doing from both the high end and the low end. But I think it's thinner. It being thin is the easiest way to describe it. Now we're trying the red coil. Okay, nothing yet. I'm really connecting. That's something I think I noticed already. It's the thickness of the wire. As of right now, nothing's happening. And these are connected. That's connected. It's connected. And nothing's happening with the red wire. The red wire is the thinnest. Yeah, I don't think no, I didn't pause it. Nothing's happening. Maybe it's because it's so thin. I don't know. It's possible. Well, I'm going to try the gold wire, which looks to be the thickest of the wires. See, that works. Okay, that definitely has the gold wire, the gold coil wire definitely has the most of the original sound, at least. I'm going to compare it in a second, but yeah, I think it has the highest inductance, mostly because of just the thickness of the wire. I think they're all the same material, but I could be wrong. So here's it with the coil again. Maybe. And here's the original. I think it loses a little bass, but I still think it has the highest inductance. I'm going to try the red wire again, connect it to the end of the wires, because that seemed to do something when I did it with the gold. Yeah, okay, I think that's what I'm going with. I think the thickness of the wire affects the inductance. The red definitely has the thinnest sound out of the 3-wire. This definitely has the fullest sound, the gold. I think it still loses a little of the overall sound, but it definitely has the best of the 3. And now for my last step, finally, I'm so sorry this took so long. I'm going to edit in series, starting with the stereo, to the coil, to a capacitor, then to the speaker. And simply, we do it in series and see what happens. Whew. Wow. I don't think the volume's noticeably changed. I'll compare it in a second, but I think the main difference is the low ends they're not gone, but they're definitely shifted down to a lower volume. They're definitely filtered out. So yeah, I mean, I guess that's what you use to make a high-end speaker. Yeah, bass is gone. I mean, not gone. It's still there, but huge difference. Yeah. Original. It's definitely what I would use to filter out bass frequencies and emphasize high ends. So yeah, that was the final step. That was step 10. So yeah, sorry it took so long. Once again, I need to stop apologizing and just end it. And yeah, I will email this to you tonight. So thanks, and that's my project.